I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Chocolate edition.
Chocolate edition. This is
So
part 2, right?
this is part 2. And last week I told you that we're going to be answering 2 questions this week.
Uh-huh.
But once I got into the research, I realized that we are only going to be able to answer 1 question this week. And it's going to be a 3-part series. We're in it. This is
Whoa.
unexpected 3-part series on chocolate that just came at us out of nowhere thanks to a question from Renee C.
Nice. That's awesome. It's been a while since we had a series, right? I feel like,
Yeah.
you know, we had insect repellents and plastics were kind of some of our longer series that we've had.
Yeah.
And cast iron / Teflon. That was like,
Yeah.
but it's been a little bit, I think, since we've had one like that.
And those have been some of our most life-changing. You know, the Teflon cast iron one has been
That's true.
pretty critical. And the plastic one has truly changed my life forever.
Yeah. Yeah, those have both been very, very impactful for me too. So let's see how my life's going to change learning more about chocolate.
Well, and there's a fun fact at the end about a way you can use chocolate to be nice for the environment.
Oh,
That's exciting.
Nice.
Well, maybe you can't, but some people can.
Nice. So like going and like giving chocolate to trees, like just being really nice and just giving chocolate to nature, you know? Nature likes chocolate.
No, that's
just like we do.
That's not it. But good try.
Okay. Well,
Really, the trees give us the chocolate, if you think about it.
but then we make it into chocolate bars and then we give it back to them because we're nice.
No, I don't think so.
Okay.
Okay, so the question we're going to be addressing today is, why does chocolate sometimes get that white film on it?
Ooh, I've definitely experienced that.
You know the one?
Oh, yeah.
It's like the white film of death, kind of.
Yeah. And then the chocolate just is way weirder, kind of like
Yes.
sometimes a little powdery, chalky, and
Yes.
weird kind of tasting and stuff.
Yep. We're going to talk about it.
Okay, weird.
Are you ready?
Yes, I am. I was just going to ask, but this might come up during, but how long it takes typically to... Questions just started rolling in my head, but one of them was just like, how long typically does it take for that white chalky stuff to appear?
Well, we'll talk about it kind of, not particularly, but we'll sort of talk about it.
Okay, but I want to find out now.
Too bad.
I'm just kidding. Oh, wait.
Okay, so chocolate has cocoa butter in it.
Right.
We talked about that last week.
Right.
And cocoa butter is just some fats. They're called triglycerides.
Mm-hmm.
Okay, so have you ever heard the term tempering chocolate?
No, I don't think so. Tempering.
So when you temper chocolate, that's where you heat it up and then cool it back down in a way that it gets that nice glossy finish.
Okay.
So if you've ever watched, I don't know, I think they do some of this on the Great British Bake Off when they're doing their chocolate work to make it glossy, or if you've ever been to like a chocolate show, they'll do that, or if you've ever tried to melt chocolate and make it into a new shape, if you temper it just right, it's nice and glossy and has a really velvety smooth texture. But if you just heat it up and cool it back down, it kind of has like a matte finish.
Got it. Okay. Weird. I've not
So
really
it's
noticed
very
that.
different. Well, I mean, if you're not super into baking shows, I could see why you would not have noticed that.
Yeah. I feel like in general, it seems kind of like, in my memory, dark chocolate, the most dark chocolate I have has that little bit more of a glossiness, and milk chocolate seems more matte, but that might be unrelated. That's like all I've really ever noticed about the differences.
I think based on what we're talking about, that kind of makes sense.
Okay.
I think. But let's talk about why, when you heat it up and cool it back down, it gets that glossier thing.
Okay.
That glossier shine.
Okay.
And a better texture. It's because what you're doing when you're tempering chocolate is actually creating a crystal structure out of the cocoa butter.
Okay.
So you want the cocoa butter within the chocolate to have a good crystal structure.
Okay.
And we've talked about what crystal structures are before a lot on the episode about if glass is a liquid. So all solids have a crystal structure. Well, I guess I should say most solids have a crystal structure. Sometimes when they solidify, it's in an amorphous form, like glass or medicine sometimes. But generally, it solidifies in an orderly way in several repeating units, and that is a crystal structure.
Right.
Some materials crystallize in one way. There's just one way that they can be arranged that's going to work well. Cocoa butter can be crystallized in 6 ways.
Whoa, weird.
So think about this like if you had some building blocks and you could create 6 different patterns out of the shapes. Something like that. That is when you have multiple different forms a crystal can take on.
Okay. Got it.
What that's called is a polymorphic crystal. That's a big fancy word. There's some things that can only crystallize in one way, like how a puzzle can only fit together in one way that works. There are some crystals that are like that, and there's some that there's multiple different arrangements you can make.
Okay. Interesting.
So of these 6 different forms the crystals can take, there's one that we can make that is really good in terms of the texture and the shine you get on the surface.
Okay. Got it. So none of the other ones have that quality. Like we wouldn't even want to make it form into the other 5.
We wouldn't really want to. I mean, chocolate still tastes fine when you do it like that. It's just not quite as good.
Oh, it affects the taste too, not just the look?
It's the texture.
Oh, that makes sense.
Yeah. So it's sort of the way it tastes. I guess the overall experience of the chocolate in your mouth is different.
One thing a phrase they use in lots of different areas, I'm sure, but also coffee, that people don't always like this, but it's just the phrase mouthfeel.
Yeah, the only way I know about that is from Brooklyn Nine-Nine.
Oh, weird.
When they're talking about his pizza blog.
Yeah, so I guess that's everywhere, but in coffee, that's where I've heard it the most, because that's the only specialty world I'm really in, but mouthfeel.
So the overall mouthfeel would be affected.
Okay. That makes sense.
There's 4 that can be made very easily that are less tasty.
Okay.
Or I guess I should say less good mouthfeel. And there's one that is very, very hard for us to make. We can't make it. It has to basically convert on its own after sitting for a while. So that's a whole other thing.
Interesting. That's crazy, dude. Chocolate's more complicated than I thought.
I know. Chocolate is way more complicated than I thought, which is why this is becoming a 3-part series.
Just look out, guys, whenever she tries to prepare the 3rd episode and it turns into the 4th, and they just
that could happen.
Keep multiplying, and then before you know it, we've had a full year of chocolate episodes.
Also, today is Earth Day. Happy Earth Day, everyone. I was hoping to do an Earth Day themed episode, but then chocolate took over my life. So we'll have a fun episode on the smell of fresh cut grass, hopefully coming at you in May.
Nice. Well, both grass and chocolate come from the earth.
That's true. That's true.
So it's not completely unrelated.
This is still sort of like Earth Day chemistry. That's true.
Yeah. In fact, to celebrate, going and getting some chocolate versus like going and cutting your grass might actually be a little more of like an enjoyable celebration of the earth for most people.
But only if it's ethically sourced chocolate. Go and splurge on some really high quality, ethically sourced chocolate that's nice to the environment and the humans who make it.
Yes, totally. And that's way easier to get now than it used to be.
Yeah, definitely. So we've talked about growing crystals before a lot in the snowflake episode. They're pretty hard to grow. In the lab, it can be very difficult. You want the exact right temperatures. You have to heat it up to where everything is dissolved, and then you want to cool it down slowly. And so that's the same is true when you're tempering chocolate, is you basically want to get it to exactly the right temperature. And it's a little bit more complicated because you're trying to get the exact right crystal structure of all the crystal structures you could make. So it's hard to get that perfectly right one. And also that perfectly right crystal form that we want is not as stable as some of the less perfect crystal forms.
Okay.
But say we get it. we've got this nice, perfect crystal form that we want. And then we leave the chocolates out, just sitting out in their packages or whatever.
Mm-hmm.
When we do that, when the manufacturers of chocolate do that, things are going to start to happen.
Okay.
And these things may happen even more if there's a filling inside the chocolate.
Okay.
And the thing that is going to happen is the white stuff on the surface of your chocolate.
Okay. So it's related to the crystal structure in a way?
It is.
Oh, okay. Interesting.
And it's also related to another chemistry lesson that we've talked about before. So we've talked about how we think that solid things are just solid and unmoving.
Oh, yeah.
But in reality, these solid things have movement at the molecular level.
Mm-hmm. Mm-hmm.
There's vibrational energy, sometimes translational, rotational, like the little molecules are in there moving around.
Right.
The electrons are able to move. So there are actually things happening in our solid objects more than we can see with our eyes.
Right. Right.
And that in itself is a chemistry lesson. That's important to know, that there's movement even when we can't see it.
Yeah. Yeah.
Nothing's completely still at the molecular level as long as energy is being put into it, which basically energy always is unless it's at 0 degrees Kelvin in the dark. You know, there's no energy forms going into it at all.
Yeah. Yeah.
So in this case, the cocoa butter inside the chocolate has that crystalline structure.
Mm-hmm.
But because there's some other fats in chocolate, especially milk chocolate.
Oh, yeah.
Or filled chocolate that has some other thing in it,
mm-hmm.
these fat molecules may be moving around a little bit. And if they come in contact with these perfectly formed cocoa butter crystals, then they might actually dissolve the cocoa butter, and then the crystals will reform in one of those less good ways without our control. They're just forming in an uncontrolled environment, one of the more stable, easier formed crystal structures.
Oh, I see. Okay.
And when that happens, if it happens at the surface of the chocolate and the crystals from the surface of the chocolate are dissolved and reform as these less perfect structures, you may be able to see the fat from the cocoa butter has reformed on the outer layer on the surface of the chocolate.
Wow. Weird. So it's a thin film of imperfect crystal structure of the cocoa butter all
and
over.
And maybe other fat that also help dissolve it. Yeah.
All over the exterior of the chocolate.
Yes. And, I mean, they're perfect structures. They're just not the ones that taste the best. They would probably still be good crystals. They're just not as pleasant crystals when you eat them.
Right.
And they call this sometimes migration because the fats are moving through the chocolate and dissolving as they go. So some of the fat is literally transferred to the outside of the chocolate. But one article that I read talked about how these new crystals are wider and they reflect light differently, and so they look more grayish. So that's part of why it also looks like a grayish white film on the outside.
Got it. Interesting.
The name of this officially is fat blooming.
Fat blooming. Weird.
Yeah, and the mechanism, they kind of know what I just told you, but a lot of it is unknown. It's still not a problem that chocolate manufacturers have been able to tackle perfectly.
Right.
So there's been a research group in Germany led by a researcher named Reinke, I think is how you say it. Reinke. And they use X-ray scattering to study the movement of oil through chocolate. I believe they powdered the chocolate. They took a chocolate bar and powdered it. And they found that if you had oil, it would dissolve the cocoa butter as it migrated through the pores in the chocolate. And that's when it would destroy the crystalline structure and likely cause that stale taste. So they think that possibly removing the porosity of chocolate, making there be less pores in the chocolate, could reduce the fat blooms.
Nice.
And then more carefully tempered chocolate with less filling is also going to help reduce that fat bloom. Because if you have more of the perfect structure, you're going to have to dissolve more things before you get those fat blooms.
Got it. Interesting.
Isn't that crazy?
Yeah. That's so weird. So for the average chocolate bar that people would buy just to have at home or something like that, is there any kind of usual time frame that the fat bloom starts to happen at a noticeable amount?
I don't think so.
Okay.
They didn't give me anything like that. Obviously, the shorter shelf life, the less time it has for the migration to take place.
Mm-hmm.
I would say lower quality chocolate that has more fats just thrown in there is probably, that aren't cocoa butter, that won't be in that crystal structure, is probably going to happen faster. And things that aren't kept at a good temperature probably could happen faster,
Or like you said, milk chocolate or filled chocolate.
Right.
Yeah.
And I usually keep my chocolate cold in the fridge, and I think that could be a way to preserve its life without the bloom longer, because if it's cold, then there's less energy in the atoms, so they're probably not moving around as much, would be my guess as to what's going on at the molecular level. I just like the snap it gives a little bit more.
Totally.
When it comes from the fridge.
Especially it's nice if you're trying to not eat it all, it's like you can snap off just a square really easily.
Or I'll get those individually wrapped squares and only put one in the fridge at a time. And so I know I'll only have one at a time because there's only one that's exactly. If I get another one, I won't like it as much.
Yeah. My brother and sister-in-law gave Em a massive, good dark chocolate bar from Trader Joe's for her first Mother's Day.
Oh, that's sweet.
And last year. And then we had that in the fridge, and Em shared it with me because it was a very large chocolate bar. But we were able to make it last a really long time because it was in the fridge. It stayed good for a while, and it made it easy to snap off just a little piece at a time. Whereas, if you have it at room temperature, you could snap anywhere. It just kind of feels like you'll get a weird, a huge chunk came off or whatever. But yeah, it was very good.
Well, that's your little chemistry lesson for the day. I feel like it's not quite a little one, I guess I should say. That's your big chemistry lesson with 2 major concepts involved in it.
Yeah. Wow.
For the day.
Jeez.
So if you want to take a stab at telling that back to me, then I'll tell you about the fun way that I learned how to use cocoa to be nicer to the environment.
Nice. Okay, cool. Let me try this. So first, like we talked about in the previous episode, chocolate bars, for instance, have a lot of stuff in there. There were 800 different ingredients in there. But we're talking about this white, film thing we see on our chocolate. There's just a few elements of a chocolate bar that are the main players in this scenario.
Mm-hmm.
So we have cocoa butter in our chocolate bars, which is actually from the cacao plant also.
Yep.
Like we talked about in the previous episode. And then there's many other ingredients depending on the chocolate bar. Like there's some milk in a lot of chocolate bars. There's some, sometimes there's chocolate that has caramel or something like that filled in there. Everybody knows this. And they all can play a role in this film thing. So kind of harkening back to the times we've talked about solid crystal structures.
Mm-hmm.
All solids mostly want to be in a crystal structure form if they
usually
can.
That's the most stable form of a molecule or a solid, is if it can have a nice repeating unit.
And just like us, they want to be stable,
Yeah, they just want stability.
Who wants to be unstable? Not me.
Not me.
So, but with chocolate and with the cocoa butter specifically in chocolate, it has many different structures, 6 specifically, that it could potentially be, instead of just one main option. It has multiple. And when you were talking about the different structures, the first thing that came to mind for me were Tinker Toys, which I played with a lot as a kid. There's lots of different versions of that same thing, but basically just having like sticks and hubs and lots of different ways that you can arrange them, and make a 3D kind of structure. And just by having a few different pieces like that, you can do lots of different kinds.
Right. Yes. It's a lot like that. And
it made me think of there are definitely times where I would orient the Tinker Toys in a way that create a stronger building. Like I always try to build things and see how strong it would be and how much how many books I could put on it or whatever. And there are other times where I would make something and it would be less strong or less stable. And as a kid, I was just, a lot of trial and error. And or sometimes you'd make it so you could knock it down on purpose because that was fun too. But that's what it made me think of. And so the different structures that the cocoa butter can be have varying degrees of stability, and they also have varying degrees of idealness for our purposes, like how the chocolate feels and tastes when we eat it, right?
Yes.
And the one that's the most ideal, chocolate makers chase the most, is not necessarily the most convenient or stable for the chocolate to be in. Is that what you said?
Yeah, I don't think it's the easiest to form, and I also don't think it's the most stable form.
Got it. So it's kind of like tricking the chocolate, the cocoa butter in the chocolate, to get into a structure that we like, but in a lot of ways isn't necessarily its preference or its...
Yes.
Yeah. Something like that.
Yeah, actually, maybe it is the most stable. I'm actually not sure. Sometimes the thing that forms faster is the less stable version. I just quickly pulled up a little infographic from, there's a website called compoundchem.com, and they do all kinds of cool stuff. And he technically isn't a peer-reviewed journal. It's just someone who's a chemist and teaches chemistry and likes to make these little graphics. And he does say that tastier one is one of the more stable ones. So I might have had that backwards, but it's not the easiest to form. So I actually am glad that you asked that. It's definitely not the easiest one to form, but it might be the most stable, and that's why it takes a little bit more time and energy to get it just right.
And it takes our intervention for it to happen for the most part, it seems.
For the most part, it seems, yeah.
So when the chocolate bar then is sitting, this is one of the things that's always blown my mind, sitting just in your cupboard, it and every other solid is actually not just staying in exactly the same place, and all the atoms in it are actually moving around a little bit and changing a little bit all the time. Especially true when you've got a lot of things you've combined into a little chocolate bar that we pushed and put in together.
It's just trying to get back to, back to its natural state.
Yeah. It doesn't like to be pushed around, which I get. Once again, I kind of relate. I don't like to be unstable and I don't like to be pushed around.
Right.
So slowly things can start to change where the crystal structure that we worked hard to make form in this chocolate bar of the cocoa butter starts to be dissolved by other things in the chocolate bar, like oils or fats from the milk chocolate, et cetera, et cetera.
Right.
And then, so that happens, but then the cocoa butter still wants to be in a crystalline structure. So then it gets its revenge by forming a crystalline structure again on the outside of the chocolate bar, but it's the more convenient, more natural crystalline structure that it can form that is not the greatest looking or the tastiest or the most stable.
Right. Not the most aesthetically pleasing either. It's no longer glossy and beautiful. Now it's just this weird, gross film.
Yeah. Did I get both parts of?
I think so. Yeah,
Nice.
I think you got it. So one thing that I forgot to tell you also is it does take a while usually to grow crystals. So like if I'm doing it in the lab, I will heat the thing up and then let it cool down slowly, and I sit it out at room temperature so it slowly cools. And if it needs to be put in a cold environment, I'll slowly introduce it to that cold environment after it's cooled down to room temperature. So I did read in one article, all these that I'm referencing are going to be in our show notes, our references as always. But one article, they were talking to a chocolatier who said actually the crystal structure takes a few days to fully form.
Okay.
So they'll package they'll let the initial cooling take place, package them up, and then in their packaging let them sit before they put them out so that the crystal structure is fully formed. And that makes sense to me because when something is solidifying down, slowly the molecules build up into this structure and will sort of settle out of the solution into the crystal. So that made sense to me. So it actually takes a few days for it to be completely crystalline.
Got it.
So they'll package things up, let them cool in a cooler or something for a few days, and then they put them out to sell at this chocolatier.
Got it. Okay. Interesting.
So I thought that was cool.
Yeah.
Meant to mention that earlier, but forgot. And then the other thing I was going to mention is that I have been using cocoa powder as a way to replace dry shampoo.
Whoa.
So a few months back, I met my now fiance's cousin. So I guess, does that mean she's going to be my cousin soon once we get married? Is it like a cousin-in-law situation?
I think it's technically cousin-in-law, but I don't know if that's a real word, but it does help people.
Do people say?
It helps people know who you're talking about. Because you just say my cousin.
Right.
Yeah.
So I met her and she showed me that instead of paying for those bottles of dry shampoo to sort of refresh your hair and absorb some of those oils, she just has a little jar where she mixed cocoa powder and cornstarch. And cornstarch will absorb that moisture and the cocoa powder will match the color of your hair.
Nice.
And so she just uses a little makeup brush to dab it on. And that is how she does dry shampoo, which is way cheaper.
Nice.
And way nicer for the environment because you're not using a can, you're not using the aerosol, you're literally just using some cocoa powder and it lasts forever. So I've been doing that since probably about January and it has been awesome. I love it. It takes some getting used to. Sometimes you have to use more cocoa powder than you think. Having a big brush to put it on with, like a makeup brush, really helps. And I have noticed, I think I get really good results if I do it the night before to give it some time to absorb those oils up. But I love it. I'm so into it. It's been a great use of cocoa powder. And I feel like it has really helped me be lower waste and nicer to the environment. And it works great.
Nice.
If you have more reddish hair, you can use cinnamon mixed in. Or there was an option for really dark like black hair, but I don't know. I don't remember off the top of my head what it was, but you can Google cocoa powder dry shampoo and see what you can mix with cornstarch to help it match your particular color.
Would I just need to use straight cornstarch or?
I think you could just use straight cornstarch, but I don't. Let me see if I can find it real quick.
That's interesting. I wonder if you could put it in, you know how like lots of powder containers, like Gold Bond powder or like baby powder or whatever, talcum powder. I wonder if you could just reuse one of those containers, because for me, I think it'd be faster to just go, I shake it on my head instead of makeup brushing it. But I also don't have, as much hair, but it'd be kind of faster to do that. But I've used a lot of dry shampoo in my day.
Well, I did try it without any brush at all, just with my fingers, and that did not go well. So yeah, she said this is just a blog I found online after I talked to my future cousin-in-law about this. And this woman, it's called wholefully.com DIY dry shampoo. She said for light and medium blondes, you can use straight arrowroot or cornstarch. And maybe just do a touch of cocoa powder to help it blend better. And then for redheads, do the cornstarch with cinnamon and maybe a little bit of cocoa powder. And then for dark, do unsweetened cocoa, which I think most cocoa powder is. So I'm not sure why she said that. But you can darken it with charcoal.
Oh, wow.
And then another one said, just activated charcoal. If you have really dark hair, you can use activated charcoal and maybe just a little bit of cornstarch. So that's really, I thought, helpful and useful.
Yeah, seriously. Seriously, that's awesome.
Yeah, I've loved it. That's been a great solution for me so far. It took some getting used to, but I think it is a way to save money and be nice to the environment. And I think it actually works a little bit better on my hair. It doesn't feel like it causes any buildup because that stuff will dissolve right away in water. So feels like I can get it really clean after I use that as well. So
nice.
I really like it and I'm very excited about it. So I just thought I'd share that since we're on the topic of cocoa.
Very cool. Yeah. And I think a lot of dudes probably haven't discovered dry shampoo as quickly as maybe they should have, but it's nice to find out about an alternative so quickly too. So if you haven't even tried dry shampoo, then don't try it and just do this instead.
Exactly. Yes, that's a great point. And I do think sometimes doing it the night before really can give it some time for the cornstarch to absorb the moisture.
Nice.
So that's a little fun fact, and I'm going to double up and use that as the fun thing from my week because I was so excited about sharing it. But so I kind of jumped the gun, but I did want to know if you had anything fun from your week that you wanted to share.
Well, mine actually has a lot to do with our topic about chocolate.
Okay.
So, you know how like there's just tons of kinds of chocolate out there, tons of little versions, small, large, or whatever. One of the most common kinds in the U.S. that we're all used to growing up is the chocolate kiss.
Yes.
So on that topic, these are not chocolate, but my son started learning how to give us kisses this week. The normal kind, not the chocolate kind. And it's very cute. He just like moves his whole mouth toward your mouth and doesn't close his mouth at all. If his tongue's already kind of out, he just leaves it out. He just like, the only thing he's really figured out is that, I put my mouth on your mouth or just put my mouth somewhere on your face.
That's pretty much it, you know?
Yeah, he's got like the most important part down for sure, to consider it a kiss. Basically, if you just pursed your lips or something, but never moved your face towards somebody else's face, that wouldn't really be considered a kiss. So he's got the most important, mechanics of the kiss down, and that was really cute.
That is really cute. Wow, look at us both doing things sort of related to chocolate. That one was cuter, though, I would say, than mine. So
true, but definitely arguably more of a stretch in its relation to chocolate. So,
well, thanks anyway, because that really brightened my day, and I love hearing about baby kisses. Edison used to do that, and it was one of my favorite things. And when he figured it actually out, it was kind of a bummer. So, thank you for sharing that little bit of baby joy with us, and thanks for coming and learning about chemistry. And thanks to all of you listeners as well. We could not do this without you, and it is such a blast getting to know you and interacting with y'all.
Yes, and thanks, Melissa, so much for teaching us about this and for opening this topic up into a multi-part dive into the world of chocolate. Melissa and I have a lot of ideas for topics of chemistry in everyday life, just like chocolate, which came from listener Renee C. But we want to hear from you. So if you have questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, or Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the costs of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee. And between now and the end of May, if you subscribe at a monthly amount, Melissa and I will send you an exclusive sticker and a note to say thank you. But if you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jerem Robinson. References for this episode can be found in our show notes or on our website. J.M. Robinson is our producer, and we'd like to give a special thanks to M. Quapple, who reviewed this episode.